FireStop Systems presents this video to acquaint you with ElastiSeal Fire Stops, a simple, reliable, and economical system for fire stopping penetration openings and thermolastic fire retardant cable coating to protect grouped electrical cables from flame propagation. Many plants today use cable rated as fire retardant in accordance with IEEE 383 standards. If this is the case for your facility, you may be thinking, why would fire breaks and tray cables be necessary if you are using Hypalon, cross-linked polyethylene, ethylene propylene, or other flame retardant IEEE 383 qualified cable insulation? These cable insulations will not propagate fire when arranged as shown to meet the requirements of the IEEE 383 flammability test. This test requires that only one row of cables be placed in the test tray and that each cable be separated from the others by a distance of 1/2 a cable diameter. Only high voltage power cables are laid this way in actual plant conditions. It should be noted, even firewood arranged exactly in this manner will self-extinguish. Next, we should be aware that the effectiveness of the two primary stimulants of flame propagation, radiative feedback and re-entry heat, are almost completely eliminated by this cable arrangement. Instrument and control cables are normally laid in the tray at random and are frequently stacked many layers deep. In this arrangement, as an example, firewood would propagate and burn every piece to ashes. In the normal random lay arrangement of control and instrument cables, insulation such as Hypalon, cross-linked polyethylene, ethylene propylene, and other IEEE 383 qualified flame retardant materials will not only burn, but will propagate vigorously, and the fire will spread vertically, horizontally, and particularly from tray to tray where stacked tray conditions exist. As a result, it has become well established today that electrical equipment rooms and other sensitive areas in major industrial and commercial buildings require fire retardant tray cable coating, even where IEEE 383 rated cables are involved, and particularly where vertical or stacked horizontal tray conditions exist. Fire breaks, shown here in white, can be spray applied in sections 8 foot high in vertical trays and sections 6 feet long in horizontal trays. These fire breaks should be spaced every 25 to 50 feet of tray cable where the cables do not pass through a penetration fire stop. FireStop Systems Thermalastic 83C fire retardant cable coating is spray or brush applied to a dry thickness of 1/16 of an inch. Thermalastic 83C is factory mutual approved to prevent flame spread among grouped electrical cables. This group of vertical fire breaks located on the side of a precipitator building are constantly exposed to exterior environmental conditions. Daily exposure to sunlight has no adverse effect on Thermalastic 83C. The coating contains two of the most effective shielding materials to protect it against harmful ultraviolet rays and resulting surface degradation. In this wider view of the precipitator building, the vertical cable coating fire breaks can be seen at 30 to 50 foot intervals. Proper application of the Thermalastic 83C cable coating by an experienced and qualified contractor will ensure fire protection of proper thickness that is clean, neat, and free from overspray. Closely stacked trays in electrical equipment rooms can be coated with equal ease and neatness. Thermalastic protects electrical cables from fire by cutting off oxygen from the fuel source, forming a surface of high emissivity that radiates significant amounts of heat away from the cables, and producing cooling vapors that greatly reduce heat transmission. Thermalastic is a single-component water-based mastic. It does not contain asbestos or any other carcinogenics. It contains no chlorines, which would cause embrittlement of stainless steel, nor glass fibers that would cause skin irritation to those who come in contact with it after application. Cables are easily removed from the coated bundle by just nicking the edge of the coating with a knife. The coating will then open like a zipper when the cable is pulled up. Even when large gaps exist in the cable bundle, as seen here, the thermolastic coating can be neatly and uniformly applied for proper protection. It is not necessary to coat every cable individually, but to simply create a cocoon over the exposed outer surface of the cable bundle. No electrical derating of the cables is necessary, as the coating's thermal conductivity is almost identical to that of PVC at temperatures below 250 degrees Fahrenheit. A slight increase in the cable diameter after coating results in a greater surface cooling area. Also, the slightly rougher surface texture of the coating creates a radiator cooling effect. All of these characteristics come together to form a tough, reliable, and economically feasible form of fire protection for high-risk areas containing large concentrations of electrical cables. For more information about this or other products sold by Fire Stop Systems, please consult the address and phone numbers found on the front of this video cartridge. We hope this video presentation has answered some of your questions and has been informative. Thank you for your time and attention.